Hi, and welcome to the next episode of Hour of Code. There's been some changes since last I did one of these videos, which was a while ago. I'm sorry for that. For one, we're now in Rider. It's been my daily driver for a few years now, and I just don't feel comfortable in Visual Studio anymore. So you'll have to live with that. So what I wanted to talk to you about today is result types and error handling in modern .NET. The traditional way to do this has always been exceptions. So let's just write some simple code that uses exception for error handling, and we'll see how that goes. So I'll just make a new class here, and I'll make a file service. It's a terrible name, but it is what it is, right? So we'll make a class called file service. We'll make a method here that loads data from a file. So we'll do public. We'll make it static. That's fine. Public static. We need a type, but I'll have this return like a list of products. So list product, get products. That's fine. No, we don't want that. We don't have a class called product, so we'll make one of those. We'll add a name, a price, maybe a description. There we go. Perfect. I'm gonna make these required. Yeah, and then just let's just try and load this file from JSON. So we'll do something like constring file path equals products.json. That's perfect. And we will do var. Well, first we should check if the file exists, right? That's just good manners. So if it doesn't exist, we have a problem, right? So then we need to throw new file not found exception, for example. That's fine. So otherwise we can assume that it exists, so we can read all the text. We can then deserialize using system JSON, system text JSON. And this looks all good. And then here, if it's null, we'll return an invalid operation exception product not found, which is fine, because the deserialize method will return null if the file contains valid JSON, but the JSON doesn't match what we're expecting, which would be a list. So for example, if it's just or if it's just null, right? Null is a valid JSON value. So this is fine. And we throw two different exceptions, and we can now call this method. So let's go back to program. Oh, hang on. I'll just make this static too, just because why not, right? And we'll go back here. We'll say hello world, and we'll change that to hello going to get the products now. Then we'll do exactly that. We're going to need to import that. That's fine. And then we'll just do found products. That's perfect. And maybe we'll loop over them. So we'll do that. Perfect. So now if we run this, we will get some errors because we haven't created the file. But let's just verify that, right? So we run it. Boom, we get an unhandled exception, file not found exception. So this is how you would traditionally, this is how traditionally in .NET we've handled errors. We use exceptions, and to handle it from out here, for example, maybe this is the happy flow. We don't want to do this if everything succeeded. Well, then we could use a try, right? So we could do a try. We'll move the product stuff in here. In fact, we'll move all of this. All of this is happy flow, right? We'll move all of this in here, tab it out. We'll catch an exception. We'll say console.writeLine. Oops, something went wrong, and then we'll print the message. Fine. Okay, let's try that now. So now we get hello, going to get the products now. Oops, something went wrong. File not found. We could have obviously updated this to include more details, like we could catch the specific exception, try to get the file, yada, yada, yada. It's not really relevant. It's just this is how you could show some errors. There is an alternative to doing it this way, though, but I should probably mention why we would want an alternative to this. So one, try catch can be a bit verbose, right? We need to have a try, you need to wrap a try block, which increases indentation level. You also must have a catch block. to catch the exception. And like for some errors, this makes sense. But sometimes it's just nicer to represent the possibility of failure in a different way. And that is what's called a result type. Now, as of .NET 8, we do not have a result type in .NET already. There is one coming in .NET 9, though. However, there are also tons of libraries already available that give you third-party result types. We're not going to use one of those today. We're going to write our own so that you can see exactly how they work, right? So we'll just go ahead and do that right now. We'll do a result type. So we'll do a class result. Now, this will need to be generic because, well, actually, let's start as if it wasn't generic, right? So we'll do a prop. We'll need it to be a bool. And I like calling it like is success. I think that's perfect. I don't want it to be get set though. I don't want it to be changeable after we've initialized. So I'll probably just do a getter. We also need a message in case things goes wrong, right? In case we have an error, we want that we want to be able to get a message. We also want the actual result. Potentially, in this case, it could be that this represents a void result. In this case, you would just have a success and message. That would be fine. But for now, we're going to cover that this also has a potential return value. So we'll do public. We'll have to do object since we don't know what it is. We can call it data or like value. I think value is a fine name. So let's call it value. So this might also be null because what if it's false? Like that's not true. So we'll make a constructor. Now we're gonna have to take in either a string message, and then this is false. So this is in case it would be an error. I wonder if that will overlap if we just do. Maybe we can't do that actually, because like what if we just want to do like object value? I think that conflicts with string. Because then you can't have a string be the return type because it will conflict them. So maybe we need to tell it if it's true or not. This is only a problem because we have such a simple case. If we were using objects for errors, we wouldn't have this problem, and that's what you would normally see. For now, let's go with this though. And like in this case, we would set is success to true, and we would set value to value, and message would obviously be null. In this case, we would just set is success to false, we would set message to message, and value would be false. So now let's test this out and see if we can get some value out of this. This is the simplest possible implementation of a result type. So we'll do here. So we'll change our file service get products. You know what? We can just copy this and we'll just make another one. We'll do get products with result, and we'll wrap our return type here with result. Now, unfortunately, we didn't make it generic, right? So we can't specify the type. But like in this case, for example, if the file did not exist, we will return new result, file not found. If the file did exist, we will instead do var data equals, or var result equals that, or we'll do, no, we can't actually do that. Okay, we have to gonna write this a little bit differently. We'll do, so if products is null, we will return products not found. Otherwise, we'll just return result over products. This can then be done like this, for example. That's fine. We'll just add a line break here as well for readability, and we can move product to its own class, own file, sorry. This is now a result version of this, and we can use that from out here. So we could comment all this code out, and we would instead do var products equals product with results, and we would check the success value. Now this is important Because while technically we can do, oh, that should be like var result. We could do if result dot value. We could access that directly, but that is not how you're supposed to do this. You're supposed to go via the is success and to like, that's how you determine if it's fine or not. So we could do if success, and here we would then, we could cast it to products because we know that result of value is a list of products in this case. And we would just do the same thing, right? Alternatively, we could write an else, exactly like the AI is here suggesting, that we can just type something out. Perfect. Now we have the exact same situation as we did with exceptions, with this simplest form of result type. So we have some issues here though. Like for example, this is just nasty, right? Like this is not nice. We don't want to do a cast here. Like it requires that we check, we'd have to read the code for this because it can't tell us. Luckily, there's ways to fix this, of course, right? We have generics. So we can just do a generic here. We can just do result t. And that means we can change this to be t value, right? And it's perfect now because now we can just say t. So now we have types associated already. So let's update this to make this a result of list product. This will then be return list product. That's fine. You need to add the types everywhere, even for cases where we return an error, because we've set the type for the type. It's not for the specific case. We could use some helper methods to solve some of this. That's actually a very common way to do this. But let's just look how this works now. So now, for example, we can just do this. We don't need to use cast anymore because we already know the type of t. So result.value is a t. However, it's going to warn here, right, that hey, this might be null, like dereference of a possible null reference. That's because if we look at result, it's this little thing here. Like we've said that it might be null, and then we have to, because in the case of an error, we don't have a value. So how do we fix that? Well, nullability has some helper attributes. They're from a namespace called code analysis. So one of them is member not null when. And we'll actually put this on is success. So I'll tell you what this does. It checks that it's only usable for bool methods. They need to return a bool. So in this case, I'm setting it on a success, which returns bool. And I say member, the member I'm talking about is value. So value is not null when this method returns true, or this property. So that means if we now go out here, because we are checking if success is true, so the code analysis knows that this in here, result of value has a value, it's not null, because that has already been tested for, so to speak. Without this attribute, you would get bad nullability warnings. So this can be quite important. It's very good to put on library code, for example. We could also do the same for message. So we could do one of these and we say false, and we do message. Now we know that message is not null. So this warning here is gone. Like, well, there's no warning because you can send null to this, but now we know that it's not going to be null here. So in case we wanted to, trim the message or search the message or something, like we can now tell the consumer that, hey, we know that this isn't going to be null. So this is so I'm just going to zoom out a little bit because it's getting a little bit big here. This is now a slightly better result type. It's still not perfect. In fact, I dislike this part, right, where I can't use string as my type, or I will get a conflict here between string and string. It won't know which one to use. So we can fix that. Let's fix that, right? So how we fix that is we remove the two constructors and we make a new one. So we'll make a new public, but we're not going to take in t value. We're going to take in bool is success. We'll take in a string and a value, and we'll all make them default. This is perfect, right? Except this, we just need to assign them as well. Perfect. Now, this should not be public. We'll make this private, and we'll make two methods here. We'll make a public static a success method, which returns, and a failure method. I prefer to call them OK and error. These are the functional names. This is like what they've traditionally been called in functional languages. While I do think they actually went with success failure in the new .NET 9 proposal. Don't quote me on that though. So now we need to update our code again, because once, like, we are not allowed to do this, right? So we have to do result dot okay. Oh, sorry, that's dot error. Here we do dot okay. Whoops, we have to remove the new dot okay, and we can do dot error. Oh, there, I flipped them around. Perfect me, right? There we go. Now I think this is slightly better, because now I could have a method that returns a result of string, and it wouldn't conflict between the failure state and the OK state, because I'm being explicit about it. The code to consume it remains the exact same, right? We haven't changed anything here. Still, we could improve on this further with implicits. We could make an implicit method so that you could just do like, hey, I want to return a result, and like we could tell it that, oh, if you want to return a result of t, then you can just do return t, and we will interpret that as a success. However, that would reintroduce the string conflict, so we would need to go to object-based errors. But you know what? Like, let's do that. This video is not very long yet, so let's show how we could introduce object-based errors, right? So the first thing we would do is we would make a new class. So public class. We could make a record, public record error, and we'll say that all errors have a message. They always have a message. Then you can add more to that by making your own. Like we could, I'm just going to move this to some file. So we'll move that to some file, and we could do public record file not found error, string file path error. Exactly, perfect. Like now we have both a new property for file path, and we also have, like, it auto calculates the message. That's fine. So we could be very explicit if we want. So now let's change up result to use this new type. So instead of message, we would have an error, and we would call this then error, right? Well, we'll need to remove these two methods now as well, because, like, well, I'll fix that. We might need to call that something else, but like we'll figure it out. We can temporarily remove these two. Well, we'll comment them out. We'll add them back once we know exactly how we want this to look. So this needs to be the error class, and that needs to be called error, and that means that is error. Wow, it really wants me to reference JS error for some reason. There we go. Now we'll probably want to fix these two. I'll have that be error. There, because now there's no, well, unless you would specify that t is actually error, which would be very bad. Like, please don't do that. So this is another variant of this. Let's see how we would use this, right? So let's first start by updating our get product with the result code to use this, right? So first we would just do return. Oh, you know, let's do the implicits, because that's what we want to do. That would be nice. So we would just return a new file not found error, right? That's what we want to do here. And then if it's we can't do this anymore because we'll change. It won't work with the implicits, I think, since we won't have explicit methods for it. You could have explicit methods and implicits. That would still work fine. But let's use the implicits. So if products is null, we would return a new error. Products not found. Otherwise, we would return new success. However, oh yeah, we removed the way to make successes. You know what? Let's not do that. Let's just do this then. Let's just add a new constructor. It doesn't want to add a new constructor. Okay, that's fine. We'll just make a new one. We'll make public result t value. There, exactly. There we go. So we'll make a success constructor. So now it's time to add implicits, because these two are not working. It says like, hey, no, you can't do this, right? You can't return an error. This method expects to return a result. So we need to add an implicit conversion method. So bear with me a second, we'll fix that. We'll make an implicit operator, result t value. This means if we pass in a t, we can convert that to a result of t. Oh yeah, must be declared static. Sorry, I forgot about that. Right. So let's make another one then for the error. So we'll make a exactly like that, and we will have to do return. We will do false, error. Yeah, there we go. You know, let's be explicit about true here as well. So we'll do true, null, value. Just feels slightly safer so that we know what that it's calling the correct overload. So now if you go out to file service, this is fine. It's saying, hey, you can do this. This is okay, because it knows how to convert this to this. So let's just fix this up, right? So we'll do result.error.message. We'll have to do that. And this is fine, even though error is nullable, right? It's like, hey, no nullability warnings, because we know that error is not null here because its success was false. So if we run this code now, everything should still work. I mean, we'll get an error, right? We don't have a file. Yeah, oops, something went wrong. File not found, product.json. Great. So we've sure, the code looks quite similar. Like instead of the try, I have the if, and instead of the catch, I have the else. Where this gets really powerful is if you use a properly designed result library, you will have error chaining, where like a method that returns a result might internally call another method that returns a result, and you could like forward the error you would get from the inner method to the caller of the outer method very easily. And that's like, that is actually like, this is how you traditionally do error handling in functional languages. And I just wanted to make like a quick little video to introduce the concept. Now, while this works, this is pretty basic and pretty bare bones. Sure, I mean, I have the implicits and I have the, you know, it's generic and I have an error type. Like, this is a step in the right direction, but there are multiple different flavors of result type libraries. For example, some of them are not just result T. You might have like T success and T error. Like that sometimes we see that. Oh, I fucked that up. My bad. We can do like that, and then I will just T error. We could do this and have the error be typed as well. The problem with that is then you need to always specify what type of error it could be. And then I don't know. I think it gets a bit too verbose. At this point, it's not so much a result type; it's just an either. And an either is a discriminated union between two values, right? You can read more about that, which we do not currently have discriminated unions in C#. There is a library called OneOff that gives us pseudo discriminated unions, and it's pretty good. There's also functional language extensions, which adds both results and OneOff, or and ethers. And these can be fine if that's what you really want. If you want to write fully functional code, you might need to do something like that. But I think this is a pretty sweet spot. I think like just having a result T is, to me, fine. Now, to wrap this up, I would like to shout out some really good libraries that handle results more with a more like even better than this little simple class we have here. Remora results. Remora.results is my personal favorite and the one I tend to use in my projects. It's part of the fantastic remora.discord library, where it's used heavily internally. But you can absolutely use it standalone too. It is a standalone library. It has result types and error types. They're beautifully made, and the code just works perfectly. In fact, if you want to know more about result types, I heavily recommend you go to the C# Discord, the unofficially official C# Discord, where there is a tag for result libs, and you will get like a list of like 20 different libraries or 10 different libraries that are all very good. They all have different trade-offs. That's why there's so many of them. Like maybe one is not perfect for you. Maybe you want explicit error types, or maybe you want better handling of chaining and stuff like that. Well, that's all I had for you today. So thank you very much, and have a good day.